Alright, let's go ahead and take a look at another example on how to add two rational expressions here. Now let's say we have something of this form. 2x over x minus 1 plus negative 4 over x squared minus 1. Now you have to try and find your least common denominator first. So looking at our denominators here, you have x minus 1, which in its factored form will still be x minus 1. There's nothing you can do. X squared minus 1, you can factor that out into x minus 1, x plus 1. Okay, because again this is difference of squares. You have basically x squared minus 1 squared, so you can factor that into x plus 1, x minus 1. So when you're trying to find your least common denominator, you can see that x minus 1 appears in both your denominators, so you go ahead and write that down once, and then you have the x plus 1, which is part of your second denominator. So your least common denominator will now be x minus 1, x plus 1. So the next thing that you will have to do here is rewrite each one of these expressions having this denominator as your common denominator now. So you will have to take 2x over x minus 1, and basically, now you can see this denominator here has only x minus 1, whereas your least common denominator has x minus 1 and x plus 1. So that tells us we need to multiply our expression here with x plus 1 so that your denominator will now look like your least common denominator. So if you go ahead and multiply your numerator, you should end up with 2x squared plus 2x over this common denominator, x minus 1, x plus 1. Now if you look at your second expression here, negative 4 over x squared minus 1, when you factored out x squared minus 1, that factored into x minus 1 and x plus 1, which is the same thing as what your least common denominator is. So x squared minus 1 and your least common denominator are pretty much the exact same thing. So that tells us I really don't need to change anything about my second expression here and just leave it as it is. So when you try and add these two expressions together, you should end up with 2x over x minus 1 plus negative 4 over x squared minus 1. When you rewrite this first expression as a equivalent expression, you will have, as we saw here, 2x squared plus 2x over x minus 1, x plus 1. And remember, we said the second expression stays the same, so negative 4, and I'm just going to go ahead and write the denominator in its factored form. So it's the same thing as your least common denominator. Now that you have the same denominator on both your expressions, you can add your numerators. So that will be 2x squared plus 2x plus negative 4, and now you can write this whole thing over your common denominator. Okay, so when we add this two together, what do we end up with? 2x squared plus 2x minus 4 over x minus 1, x plus 1. Now what you want to do is try and see if you can factor your numerator and maybe reduce this fraction any further. So let's try and see if we can factor the 2x squared plus 2x minus 4. Now anytime you have a leading coefficient which is not 1, your rules for factoring will be a little bit different. So as you can see, your leading coefficient here is a 2. So that tells me your first two terms will be 2x and x, because when you multiply these two together, you should end up with 2x squared. Now, when you are trying to split your middle term, what you will do is take negative 4 and multiply it into 2, okay? Take the negative 4, multiply that into 2, so that will give you 2 times negative 4, which is negative 8. And now you will find factors of negative 8, which will add to give you the middle term, which is positive 2. So factors of negative 8 that will add to give you a positive 2. How about positive 4 and negative 2? When you multiply positive 4 and negative 2, you get negative 8 as your answer. And when you add positive 4 with negative 2, you get positive 2 as your answer. Now the important thing that you have to keep in mind is, does the 4 go on this side or does the 4 go on this side? Which factor will the 4 be a part of? In this case, I would just say, do a little bit of a trial and error. If you put 4 here and negative 2 here, go back and multiply the two factors and see, do you come back with, the original statement? If it's not the same, then it means that you need to switch the order. So it will actually be a situation where you will put 2x minus 2 as the first factor and x plus 4 as your second factor. You can try and multiplying this and see what answers you come up with. Okay, now once you factor these out, you can see that we still don't have any common factors between the numerator and the denominator. But if you look at your first factor here, 2x minus 2, you can see that 2 is common between both our terms here. So if we pull that 2 outside as our common factor just from here, that will leave us with x minus 1, because this 2 goes outside and 2 divided by 2 gives you 1. The x plus 4 stays the same, and of course your denominator stays the same. Now once we take that 2 outside, you can see that you have x minus 1 that is common between the numerator and the denominator. And this expression in lowest terms will be 2 times x plus 4 over x plus 1. Okay? So sometimes these can be a little bit more involved than what you had started out with. But as you can see, if you just follow the steps, follow the instructions, then you can come up with a pretty clean and simple answer here. Okay, so that was our second example. Now let's go ahead and take a look at one more example here. We're still trying to do the same thing, add two different expressions with two different denominators. Now in this case, your first expression is a over a squared plus 3a minus 4, and you're adding this to the expression 4a over a squared plus 7a plus 12. So again, remember, the first thing is find your least common denominator. So we will start out by taking each denominator and factoring it. Okay, so a squared plus 3a minus 4, when you factor this, that will give you plus 4 minus 1, okay? Plus 4 minus 1 gives you negative 4 when you multiply, and 4 minus 1, of course, gives you positive 3 when you add. So we'll do the same thing for our second denominator, a squared plus 7a plus 12. Factor it first. So again, your leading terms will be a, and then factors of 12 that will add to give us 7 will be 3 and 4. positive 4, positive 3. Product is positive 12, and when you add the two together, your sum is 7. Okay, now once you factor your denominators, you can easily now try and see what your LCD, or your least common denominator, is going to be. Now both the denominators have a plus 4 common, so we'll go ahead and write that down once. And then you had an a plus 3 on the second one and a minus 1 on the first one. So whichever denominator is common, you go ahead and write it down once, or basically as many times as it appears. That's the maximum number of times it appears in one denominator. Then you go ahead and write all the others that were not common. So a plus 4 times a plus 3 times a minus 1, that's going to be your LCD for this expression here. Now that we have our least common denominator, that tells us we need to find equivalent forms of our rational expressions here. So let's go ahead and see what's going to happen now. So the first thing you want to do is rewrite a over a square plus 3a minus 4. Now if I just rewrite this, instead of writing it as this, I'm going to go ahead and write it in its factored form. It's going to be a plus 4, a minus 1. Okay, so I'm just basically taking this expression, and instead of writing it as a trinomial, I'm going to go ahead and write it in its factored form. The reason I do that is because in this form, it's easy for me to see with respect to the LCD what factors I don't have in my original expression. So you can see we have a plus 4, we don't have a plus 3, but we have a minus 1. So that tells me I need to multiply this expression with a plus 3 so that my denominator will look like my least common denominator. Okay, so you multiply this whole expression by a plus 3, and you will end up with, in the equivalent form, this will be a square plus 3a. Okay, when you multiply your numerator, denominator stays the same, a plus 4, a minus 1, a plus 3. Okay, so that was the first rational expression. You want to try and do the same thing for your second rational expression. Okay, so you'll take 4a over a squared plus 7a plus 12 and do the same thing with them. So let's see. 4a over a squared plus 7a plus 12. Go ahead and rewrite your denominator in its factored form, which will be a plus 4, a plus 3. Okay, now let's compare this with our least common denominator. Now your least common denominator is a plus 4, a plus 3, a minus 1. You have a plus 4 and a plus 3. What you're missing is the a minus 1 factor. So we multiply this expression with a minus 1, and now we will end up with 4a squared minus 4a, and now your denominator is going to be the same as your least common denominator. So both my expressions now have the same denominator, so now we are ready to add our numerators together. So let's see what we're going to end up with. So you have a over a squared plus 3a minus 4 being added to 4a squared plus 7a plus 12. Okay, so in their equivalent forms, we will write these as a squared plus 3a over a plus 4, a plus 3, a minus 1. And we're adding this to the equivalent form for the second one, which will be 4a squared minus 4a over the same denominator, a plus 4, a plus 3, a minus 1. Alright, so now we can add our numerators together. So you have, let's see, a squared plus 3a plus 4a squared minus 4a, and this whole thing over your least common denominator. Okay. Now all you have to do for your numerator when you're trying to add these together is combine all your like terms together. So you can add the a squared with the 4a squared, so that will give you 5a squared. You can add the 3a with the negative 4a. 3a minus 4a will just give you negative a. And of course the whole thing is over a plus 4, a plus 3, a minus 1. Now, once you add them together, you know the next thing you have to do is try and put it in lowest terms. So we'll start by factoring our numerator. Now both our terms have a in common, so you can pull the a outside as your greatest common factor, which will leave you with 5a minus 1, because again, you had a squared, you took one of the a's outside, so you're left with just 1a. On the other side, you had an a divided by a will give you 1. So we can pull that a outside, and let's see, denominator still stays the same, a plus 4, a plus 3, a minus 1. But once you put it in the factored form, you will still notice that there is nothing common between the numerator and the denominator. So actually that tells us this is already in lowest terms and you cannot break it down any further. So this will be your sum to your original problem that you started out with, where you were adding a over a squared plus 3a minus 4 with a 4a over a squared plus 7a plus 12. Alrighty.